Hi, in this video you will know the Databricks optimization points, and these optimization techniques are much useful in our interview as well as in your projects. So what we will cover in this video: if you are running your workloads on Databricks, there is a good chance you are paying for more compute than you need, or waiting longer than you should for queries to finish. In the next few minutes, we will walk through the highest impact ways to optimize the Databricks environment across compute, storage, query performance, and cost. Let's get into it. So, compute optimization. In the compute optimization, we'll cover here 5 core pillars for compute optimization: storage, delta laking, query, and job level performance, cost controls, and governance and monitoring. And we will close with a quick win checklist: 6 things you can implement this week without a major re-architecture. Right size clusters. Second one is enable auto scaling. Third one, use the Photon engine. And fourth one, prefer job clusters. And fifth one, apply cluster policies. We'll see in the compute optimization what you will see. In the compute optimization, let's start because it's usually where the biggest waste hides. First, right size your clusters. Match instance family to workload memory heavy jobs. They need memory optimized nodes, not general purpose one sized by guesswork. Second is turn on auto scaling. Instead of provisioning for peak load all day, let the cluster grow and shrink with demand. Third, and this is the big one, enable the Photon engine. It's a vectorized execution engine that can cut runtime by 2 to 3 times on SQL and data frame workloads, often with 0 code changes. The fourth one, prefer job clusters over all purpose clusters for anything scheduled. Job cluster spin off, run and terminate. You are not paying for idle time. And finally, apply cluster policies so teams can't accidentally spin off an oversized, unterminated cluster and quietly burn budget. So the next quick point is storage and delta lake optimization. So what you will cover here, you see optimize, G-order, partitioning, vacuum, auto compaction, and caching. So next, storage. This is where delta lake gives you a lot of levers. Run optimize regularly. It embeds small files into larger ones, which reduces metadata overhead and speeds up scans dramatically. Use G-order or liquid clustering on your runtimes. On the high cardinality columns, you filter on most. That co-locates related data so queries skip more files entirely. Be thoughtful with partitioning. Partition only on low cardinality columns. Over partitioning actually creates the small file problem, and you are trying to avoid. And schedule vacuum to clean up stale unreferenced files once they are past your retention window. Turn on optimizer writes and auto compaction so delta handles file size automatically, reducing how often you need to run optimize manually. And use delta or disk caching for data you read repeatedly. It keeps frequently accessed files close to compute instead of refetching from remote strategy every time. Query and job level optimization. Now let's talk about the query and job level. Enable adaptive query execution, or AQU. It re-optimizes the query plan at runtime, coalescing shuffle partitions, and automatically handle skewed joins that would otherwise slow everything down. Use broadcast joins for small dimension tables. Broadcasting avoids an expensive shuffle on your large fact table. Minimize shuffles in general. Filter rows and select only the columns you need as early as possible in the pipeline. Cache judiciously. Caching data frames you reuse across multiple actions helps, but over caching just wastes cluster memory. When something is slow, don't guess. Review the Spark user interface, UI, or query profile to find the actual bottleneck, whether that is a spill or whether that is a skew or a scan issue. And for long running pipelines, split them into stages with checkpoints, so a failure doesn't mean reprocessing everything from scratch. Cost optimization. Now cost, because performance and cost optimization go hand in hand. Use smarter preemptible instances for fault tolerance batch workloads. It's often the single biggest cost lever available, and Databricks handles the fallback if spot capacity gets reclaimed. Set aggressive auto-termination on interactive clusters. A short idle timeout means you are not paying for a cluster someone forgot for shutdown. For bursty or ad hoc workloads, consider serverless compute instead of an always on cluster sitting idle between queries. Right size your workspace tier, standard, premium, or enterprise to match the features your workload actually needs. And tag your clusters and jobs. It sounds simple, but cost attribution is what makes teams accountable for their own spend. Put these together and it's a realistic to cut compute spend by well over half, as this illustrative example shows. And governance and reliability and monitoring. Optimization is not just about speed and cost, it is also about reliability and control. Centralize access with Unity catalog so permissions, lineage, and auditing are consistent across every workspace, not managed ad hoc per team. Configure alerts on jobs and clusters so failures or SLA breaches show up in your inbox or Slack channel, not 3 days later in a postmortem. Track query history and set up SQL alerts to catch cost or performance regressions early before they become a pattern. Make sure streaming jobs checkpoint reliability so a failure means a clean resume, not a full reprocess. And periodically review the system tables for utilization and billing. They are often the fastest way we spot waste you didn't know existed. And in the quick checklist, if you only take one thing away from this, make it this checklist this week. You can turn on auto-scaling and auto-termination, switch to the Photon engine, run, optimize, and vacuum on your hottest tables, enable adaptive query execution, move eligible batch jobs to spot instances, and set up job failure alerts. None of these require a redesign. They are configuration changes you can make today. Finally, optimization on Databricks is not a one-time project. It is a habit. Workloads grow, data volumes shift, and a cluster that was perfectly sized 6 months ago might be quietly wasting money today. Revisit these 5 pillars on regular cadence and they will keep performance high and cost predictable. Thanks for watching.